All right, so the first one, you got to go through and FOIL. 2 times 3 first is 6. Then 2 times negative square root of 5 would be negative 2 root 5. You come back and have root 5 times 3, which would be means you need to add 3 root 5. And then a positive root 5 times negative root 5 is just going to be a negative 5. Skip a step. The step I skipped is negative square root 25, which by now, if you square a square root, you get the root. You need to understand that by now. So 6 and minus 5, or 6 minus 5 will be 1, and then negative 2 root 5 plus a 3 root 5 will be a 1 root 5. So your answer would look something very similar to that. On the next one, we have square root of 75, which is a 25 times 3. We're going to try to pull out perfect square factors. And then 12 is a 4 times 3. 25 can be brought outside the radical as its root. Same thing with 4. Can be brought outside the radical as a 2. So you end up with 7 square roots of 3, since they both have a square root of 3. 5 to the 1/7 power is a 7th root of 5. Don't write the 7 big and out front like that. That's not what it is. It's not 7 times the square root, it's the 7th root. The next one, if you're going to, since we have like bases, as multiplication, we're going to end up adding the exponents. So we have m 2/5 plus 1/5, already have a common denominator, it's 3/5. That's all you have to do. Okay? Don't write it as m, and I didn't write it very well, like this. Okay? Make sure it's smaller, it's raised up as an exponent type answer. The next one, we need to solve this. Since we have only the radical part on the left side, we can square both sides. So when you square both sides, make sure you square both sides. Some people are forgetting to do that. When you square the left, the radical comes off. But make sure you square the right also. Then solve it just like you would any other algebra problem. Subtract 4 from both sides. Divide both sides by 3. And x would be 7. On this next one, I told you to put a 9 here, I believe, right? Okay. So we would want to subtract 2 first, so that we have only the radical part on the left side. Now we don't reverse it when we subtract. We reverse it when we multiply by negative. Then we can square both sides again. The radical comes off like it did before. So we have 5x minus 1 greater than 49. Add 1 to both sides. I'm going to work up. 5x greater than 50. Divide both sides by 10. X is greater than 10. Now we do need to make sure that none of the values greater than 10 are going to cause this to be negative under the radical. They won't. Anything greater than 10 is going to leave you with a positive under the radical. So we're okay with leaving the answer like that. One is in radical form, one is in exponential form. You just need to get them the same. You want to put them both in radical form, that's fine. You have fifth root of x divided by, that would be also fifth root of x. And anything over itself is 1. On the next one, since this is multiplication, we want to get y by itself. We're going to divide by 2 to the 8th on both sides. Cancel over here. Y would be equal to, you're dividing, you have like bases, you need to subtract the exponents. But I have more on the bottom, my exponent is larger on the bottom than it is on the top. So 1 over 2 to the third. Two to the third is what? 8. So I saw some answers, and I think on the quiz it was written as 2 to the negative third, which is correct. Out of all the answer choices it gave you, it was the only one that was correct, but it's not the best way to write it. What's the best way to write this? 1 over 8. We understand 1 over 8 a lot better when we do 2 to the negative third. What an eighth of an inch looks like? Half of a quarter. If I told you to cut off 2 to the negative third of an inch of a piece of wood, that wouldn't make much sense. But if I told you to cut off 1/8 of an inch of wood, you know what that meant, or most of you. That's the best way to write it. 256 is 2 to the 8th power. It's also 4 to the 4th power. But totally broken out, be 2 to the 8th power. And either one will work, you'll get there. 4 to the 4th matches t to the 4th a little bit better. So if we called that 4 to the 4th times t to the 4th, we need exponents with 3. So we're going to break it down to 4 to the 3rd times 4. That's the same as 4 to the 4th. And t to the 3rd times t. That's the same as t to the 4th. But the reason that helps is because that can come out as just 4. That can come out as just t. 4t outside the cube root. And this 4 and this t stay underneath the radical. We good? All right, let's look through these. Again, when you have a radical, you need to try to find, and since this is a square root, you need to try to find any perfect squares that are factors and break those out. So 32 has 16, which is a perfect square, as a factor. 16 times 2. 18 has 9 as a factor. 9 times 2. 54 has what as a factor? 9. 9. So 9 times 6. And then 150 also has, or has 25 as a factor, times 6. So then these perfect squares will get brought out as their square root. So this will become 4 root 2. That'll become 3 root 2. Signs between them will stay. This will become 3 root 6. That'll become 5 root 6. So you have 2 that are of like terms. There are 2 of them that are root 2 types, and 2 of them that are root 6 types. So the root 2 types can go together. 4 minus 3 is 1. So I got 1 root 2. and 8 total root 6s. The next one is one that we probably haven't done enough of. When you have a binomial in the denominator, one of those terms is a radical. In order to get rid of that radical, you have to multiply by its conjugate, which looks just like it, except it has an addition sign in between. You're actually multiplying by 1 in the form of the conjugate with the denominator over itself. But the reason this helps, and try to understand why this works, and if you understand why it works, it'll be easier to remember what to do. When you FOIL this out, 2 times 2 is 4, and then you get a positive 2 root 3, and then here you get a negative 2 root 3, which will cancel out the root 3's in the middle, but then also you'll cancel out the root 3's when you multiply negative root 3 times positive root 3. That just becomes plain old 3, plain old minus 3. So that's the denominator. Okay? This is all I'm working with here is the denominator. 4, 0 pair, minus 3 is 1. Now let's talk about the numerator. This is multiplication. 5 times 2 is 10. 5 times root 3 is 5 root 3. I don't need anything written over 1. So my answer should look like that. Next one says to use rational exponents, exponential form. The index is the denominator. So the 5 goes down here. The exponent on the m is the numerator. And since this is, the numerator is smaller than the denominator, I can stop. In the next one, I have like bases, so if you divide or multiply with like bases, you'll either add or subtract. In this case, divide means you'll subtract. So we need to have t to the 3/4 minus 1/5, which will need a common denominator. Between 4 and 5 is 20. So I have 15 over 20. So I'll multiply through this one by 5 over 5. And I get 15 over 20. This one by 4 over 4. 4 over 20. 15, wait, there it is. 15 minus 4 is 11. So I just write it as t to the 11, 20 power. Can't reduce 11 over 20. If we could, then that probably means we didn't find the least denominator we could have used. That's right. So solving this, we need to add 1 first, so that we have the radical by itself on the left side. 3x plus 6 greater than or equal to 6. Then I can square both sides. That will kill the radical. Subtract 6 and divide by 3. Subtract 6, I get 3x greater than or equal to 30. Divide by 3, x is greater than or equal to 10. I need to check and see if any number greater than 10 is going to cause that to be negative. No. Everything greater than 10 is positive, so I'm okay. Now, this one has a lot of junk going on. We got negative exponents, we got mixed radical and exponential form, we got division. So let's just figure out, what does this mean? You're dividing by x to the negative 5 halves. Let's just put them both in exponential form. This is x to the 5 halves divided by x to the negative 5 halves. So the rule says to subtract if you're dividing, but if I subtract a negative, what do I really do? Turns into addition. So you can look at it as subtracting negative, or you can go ahead and first move this to the numerator and make both of their exponents positive, and you get x to the 5 halves times x to the 5 halves. Now they're both positive with like bases. So I add the exponents together. I already have a common denominator. 5 halves plus 5 halves is 10 halves. Also known as, you got 10 halves, you got a 10 halves of a pizza, that's 5 pizzas, right? Yeah. You already ate. So as I'm working this out, the first thing I would do is what? Add 3. Whether it's written as to the 1/3 power or cube root, it's gonna act the same way. Let's write as cube root. Well, yeah, it doesn't matter. Cube root, 5c minus 1. If we add 3, we get equal to 4. Now we can cube both sides. But first, let's see. Do I have this anywhere up there as one of my answer choices? No. So I got to keep going. Because there's a couple steps, and it's looking for one of the steps in the sequence. So if I cube both sides, kills the cube root, so I'm just left with 5c minus 1. And 4 to the 3rd is 64. Is that up there? J is one of the steps in the sequence.